Hello, so today we are going to continue on problems for weekly contest 401. The second problem is find the nth value after k seconds. So again, still in the pattern of k seconds. We have two integers n and k, and we start with an array of integers and integers where all of them start out with value 1. Okay? And then after each second, again, similar pattern to the first problem where after each second something happened. So here, after each second, we simultaneously, this is very important, this simultaneously part here, because that means it happens in parallel. You don't do one and then for one index and then use the updated index to update the other one. No, use the original index. You do all of them simultaneously. And you update each element to be the sum of its preceding elements plus the element itself. Okay? You do that for every element simultaneously in parallel. And then after 1 second, so basically that means after each second, all of them change except the first element because there is nothing before it, right? And so what happens after 1 second? The first element stays the same. The second element, A1, becomes itself plus the previous element, which is A0. A2, it's itself plus everything before it, so plus A0 and A1. And you do the same for A3 all the way to the end. Now the goal is, given a k value, k seconds, we want to return the value at the last position after those k seconds have elapsed. Knowing that for each second we do this operation where we accumulate every element up to the index of that element. Now since k can be really large, k can be up to 1000, so you can imagine the elements can get really big, and so we want to use a modulo, okay? Now, if you look at the bounds here, it's 1000. So if we do something really quick, it should pass if we use a fast operation. So what is the most straightforward way to do this? Well, first let's just create our initial array, which is going to be 1 for all the elements. Okay? And then we need the mod value, right? So we can pass it. Now for every second we want to do the updates. So what are the updates? Well, the updates is for every element we want to basically make it be the pluses, right? Now I'm going to do something here. Let me just show you first before I run this. In Python you have this accumulate concept where you could take the array. So let's say we create our A array, and then we use a knitter tools function called accumulate, which just accumulates the array. But let me show you what that returns. So okay, so let's run this. Let's return 0 just to satisfy the return. So you can see it does exactly what's asked here. Right? It accumulates each element with the values to its left. Right? So let's do it a second time. Let's assign this to A, just so you can see, and then do it one more time, and print it again, and see what happens. Okay, so you can see. Let's also print the initial one. Okay, so first we start with ones. Then you can see the second position is just the accumulation of these two. This one is the accumulation of these three. This one is the accumulation of all those to the left. Okay? And then second we take this array, we do the same thing. 3 is 1 plus 2. And then 6 is 1 plus 2 plus 3. And then 10 is 1 plus 2 plus 3 plus 4. Okay, so it does exactly what we are being asked. And so we don't need to actually go in and do it manually. And so if we go back to our function here, that's exactly what we need to do, right? But remember, we also need to do the mod because k can be really big. So here we need, for each value here, we want to take, we don't need list if we do this, we need to take the mod. Okay. And that's pretty much it. Now what should we return? We want to return the last position. So in Python you could just do it like that. Okay, so let's run this. Looks good. Let's try to submit. Okay, so that gets accepted, but now technically this is accumulate is at least O of n. This is O of k, so it's O of n k. With 1000 overall is 10 to the power of 6. So it should pass, but it's borderline. Okay, so a different way to do this that may be easier also to grasp is, let's consider this like if it was a prefix sum. So first we initialize all of them. Then here we just go through the indexes, right, up to n. Now for each element, let's say for p0 plus p1, right? Once we will put plus p2, so p2 will be equal to this on this current iteration. Then p1 is in parallel, if we do this in parallel simultaneously like the problem says, plus p1. Okay, and then p0 stays as p0. Okay, so what do you notice? If we don't do this in parallel, if we don't do this one after the other, if we use the updated p1, then we actually, this is just going to be, this here is just this, right? So p1 plus p2. Same thing for p3 is going to be just the updated p2 plus the previous element of p3, right? So you can see here for each one, this is going to be just p1 plus p0. This is p2 plus p1. This is p3 plus p2, and we keep going like that. So you can see for each p of I is just going to be, we just add the updated value of pi minus 1. Okay, so here it's just going to be pi plus pi minus 1. Of course we don't change, we start from 1, okay, and then we decrement k. Okay, here also, since we do it for all k seconds, we can just do for a range of k, right? So, and this is just, let's have it be p of minus 1. This may be easier to grasp, and so if we submit, yeah, we forgot to do the mod, so we need to do p of I plus this modulo mod. Okay, we'll submit. And this gets accepted. Okay, now one other thing you can notice if you try this is, you can notice that we start from 1. This is Pascal's triangle, and so you can if you just print the if you print just the accumulation, so if you print after each one, you just print p, right, and print the position k, right, like that. You can see for the first one, k equal to so this is, let's call it ki, that's what we need to print. Let's call it like that. So for k equal to 0, the value is 1. For k equal to 1, the value is 3. For k equal to 2, the value for is 10. So now looking at this and looking at the Pascal triangle, do you see any resemblance, right? Let me just bring these here, put this here, so we can see more clearly. So this is the Pascal's triangle, and this is, for example, what we printed for like 5 seconds, for 20 runs 5 seconds. And I want to show you if we can deduct something. Okay, so if you look at these, do you see any difference? Well, we definitely see 1, 2 here. We definitely see 3, we see 6. Okay, so we see 1, we see 2, we see 3, we see 4, we see 6, we see 10. So the values are awfully similar, And one of the solutions here, if you look at it, you can find that it's actually just, if you look at the Pascal's triangle sort of sideways, it's the exact values. So what I mean by that is it's, okay, let's look at just this side here. So this is the same as the initial one that we didn't print. This one here is the same as after 1 second, after the first second. Now, our n for the first example is equal to 4. So we only need to look at the first 4 in the diagonal. Now, 1, 3, 6, 10, that's exactly this one. 1, 4, 10, 20, that's exactly this one. And then 1, 5, 15, again, that's this one. And then 1, 6, 21. If we print more of the Pascal triangle, you will see that here we have 56, but that's this one. And you keep going with Pascal's triangle. So that's really clever, but how do we use n and k here to find it, right? So if you look at k is the number of seconds, right? And n is basically the number of the number, basically n tells us how many we should look at in the diagonal, right? And so, for example, for k equal to 8, right? So let's see here. So if you look at the index k, so we take 8, that will give us the k plus n minus 1, that will give us the value, and then we can just modulo it. Now, how do you do that? Because the kth entry in the nth row of the Pascal triangle is actually the combinatorics of n minus k. So the kth entry of the nth row. So here for row 8, we need to look at, if we want to look at the kth entry, so 0, 1, 2, 3, then we can just get the combinatorics like this. Okay, so this is basically the combinatorics of k plus n, choose n. And so we can just use that value and calculate it. I'm not going to write it down, but this is just something to make you think about using this Pascal triangle. I find it really interesting that if you just visualize it and remember what the values of the Pascal triangles are, you can just sort of deduct it. But definitely this method is way harder than just doing the brute force way that we did here. Yeah, so that's pretty much it that I wanted to share for this problem. Thanks for watching, and see you in the next one. Bye.